grab your favorite red writing utensil. Homework 6F-1. Volumes with cross sections. Here we go. Remember one we did together, right? I'll do it again anyway. 64 pi over 5. Number 1 is 64 pi over 5. Number 2. This is an actual nice number. I'll accept either 512 over 5 or 102.4. Number 3. It's exactly 288. 288. Number 4. The answer is 8 radical 3 over 15. 8 radical 3 over 15. And number 5, 128 pi over 15. 128 pi over 15. Repeats.
Sorry, would you repeat the last one?
Yeah, 128 pi over 15.
Thank you.
No problem. Any repeats? All right, questions? Anything we want to see dissected? Yeah.
Can you read number 4?
Number 4, yeah. Base of a solid is enclosed by y equals 1 and y equals x squared over 4. I'm going to write this as 1/4 x squared. So a quickie graph here starts at 0, 0. Ah. We're just going through the worksheet, so we're going to be going out. 1/4 x over 1 up a fourth over 2 up 1. So there's the shape in question, right here. It says if you slice perpendicular to the x-axis, they're equilateral triangles. Here's what this would look like. If you just picked a random slice, it would stick out like this. Like a piece of cheese pointing out at you. Does that make sense? Now the question is, what's the area of that triangle? Somebody remember the equilateral triangle area? Yeah. S squared radical 3 over 4. Or you could write it as radical 3 over 4 s squared. Doesn't really much matter. I need to know which dimension. Let me just enlarge this over here. It's going like this, basically. Does that make sense? What's the area of this thing? Now, if it's equilateral, all these sides are the same, so it doesn't really matter where you start. But how long is that? This is a little tricky. If I picked a random point here and went up from 0, that's y. Y is the height of the graph. The stuff above it is not the height of the graph. Any idea how to get it?
Is it just what we did with the previous problem, like 1 minus 1?
Yeah. If you look at here, I'm just going to zoom in here. So if you've got, let's just say this is a distance of 8. I'm just making this up. And this is y, the graph of y. Here's the x-axis. Any point here, that's going to be y. Does that make sense? Because y is the height of the graph. How much is this total? B. What's that total length? 8. If the bottom is y and the total is 8, how do you get this?
4.
Can't guarantee that. might be 5, might be 3.5, might be 6.
Um,
But if the total is 8, and you know this is y, how do you find the missing part?
Did you subtract that from the
Tell me the formula.
8 minus 1?
That's exactly what you use. The thing on top is 8 minus y, or in this case, since this is a height of 1, this is 1 minus y. So the length of your equilateral triangle is 1 minus y. See why that's true? It's not y, it's 1 minus y. So let's try this. Every single slice is going to be this as a side. So the area of that triangle slice is equal to now there are two things. They're either doing one of two things. They're either getting more raccoons off the roof, or they're setting up for fixing the Wi-Fi, both of which are good. So I will not disturb them. It's 1 minus y squared radical 3 over 4. Clear? Or you can write it as this. Radical 3 over 4, 1 minus y squared.
They're getting more
They're getting a
raccoons.
raccoon.
Are you serious?
They have traps.
Nice.
You have got to be kidding me.
Wow.
What's wrong with that?
God bless
They
you.
bring it in here, I wanna see it.
Yeah, that's a good thing. You don't want raccoons like falling.
No.
down
It's,
on
I'm
us.
glad they're doing it. Right. And you don't want raccoons falling off to their demise, which is put them in the
I
woods where
don't
they're
care
not.
about that.
Okay, moving on from raccoons to calculus. Now, the area of the slice is fine. What's the volume of the slice? There's one extra thing you have to include in order to get the volume of this triangular slice. Jack, what is it?
I don't know, I totally did it wrong, so.
Okay, how do you get the volume of any slice? Like this is a triangle, here's the area.
Oh,
How do you get a
add
volume?
like a dx or?
Right, you multiply it by the thickness, which in this case is what? It's dx, because it's sliced in the dx direction. So the volume is the exact same thing as they had before. It's the base area
Did you just say hi, little guy?
Wait,
times the height.
Mr. Tolbert.
wait, Mr. Tolbert,
Mr.
can we see
Tolbert.
it? Can we see it?
No, no.
Please.
No.
Please, Mr.
Don't even.
Tolbert.
Empty trap.
Aww.
Oh, that's okay. We already caught the mom and the baby, so
Sweet.
So what is
that's what we do.
It's over for the next game.
All right.
Question, okay, drag you back from raccoons to here. How do you get the total volume of this thing? There's a whole bunch of triangles stacked next to each other. Total volume is what? Yeah. The integral. The integral of radical 3 over 4, parentheses 1 minus y squared, dx. From what to what? Good decision. From what to what? Are you using x's or y's?
X's.
X's. So from what to what? According to the picture.
-2 to
Yeah, from -2 to 2. If they'd been using y's, I'd have to go from 0 to 1. From -2 to 2. Everybody have this written down who didn't get it? It'd be helpful if you did. This is the integral. What's wrong with it, though, Holly? Why can't I not just take the integral now? Yeah, you have to replace the y with what? Exactly. So it's going to be the integral from -2 to 2. By the way, see the radical 3 over 4? Just pull it in front. You want it to trip over it. And it'll be parentheses 1 minus new parentheses 1/4 x squared parentheses squared. Can you expand that and dx at the end? Can you expand that? Yeah, you could. Do you have to? No. what you do is square the first, double the product, which is a little annoying, and then square the last. You could. I'm not sure it would be any shorter. Grab your calculators. Let's try this one. Where's my calculator? There. So type radical 3, close the parentheses, over 4, and then math 9. Then start the, well, they give you a parentheses if you have the old calculator. By the way, if you have a new calculator and it just gives you a little space here, I would still put a parentheses here, because we have to square the entire thing. So even if you have the old calculator, do an extra parentheses. Then 1 minus new parentheses. 1/4 is nice enough, you can just put 0.25 if it's easier. Or you can do 1 divided by 4. X squared. Close the parentheses, squared, comma, x, comma, -2, comma, 2. See what happens. This was number 4, right? Oh, I'm an idiot. The radical 3 is going to destroy our ability to get the fraction. Save the radical 3 over 4 till the end. Bless you. Just do the integral. Delete. Okay, what do you get? Just the integral, not the radical 3 over 4.
Square should be.
Can we get it?
It's 32 over 15.
Yeah, 32 over 15. This is radical 3 over 4 times 32 over 15. Does that reduce? To what? Give. What reduces?
Radical, well, the 32 is what?
The 32 and the 4 go down to what?
8.
8 n. And say again?
15. Well, there's
Yeah, just a 1. So what do you get?
8. 3 over 15.
Got it. And that is your answer. Does that make sense? Questions? Yeah, if you have an irrational number in there, don't throw it in if you hope you get an exact answer. It's kind of like having pi in there. Save it to the end. Good life lesson too. If something's irrational, save it to the end. You'll be in a better mood. Alrighty. Any other ones you want to see? Yeah. Number 3. Yes. Base of a solid. Let me get this thing out of here. Is the region enclosed by the semicircle? It's nice to have a semicircle equation every once in a while. 36 minus x squared, gentlemen in the back, please focus. Cross sections are that are perpendicular to the x-axis are squares. So let's graph this thing. How do you graph this? Talk me through it. You have the capacity to do that. You could use a chart if necessary, but what shape is that again? Feet.
That would be a parabola.
If it were without the radical, yes.
Oh, would it just be a straight line?
It's not. A lot of people assume it is, because people assume it's 6 minus x, which by the way is totally wrong. Because the addition subtraction messes up the radical. It's a semicircle. Yeah, the instructions say it was. If it's a semicircle, it's got to have a center and a radius. Where's the center? Yes, there are 2 numbers. 0, 0. What's the radius? Anybody see it? I'll show you a quick way. If they say it's a semicircle, here's a quick way to see where it came from. Look up here. Everybody. Square both sides. What do you get? Anyway. John, go ahead.
Y squared equals 36 minus x squared.
Yep. Get rid of the x squared.
So I add x plus x. So y squared plus x squared was 36.
Right.
Which is R squared.
That should be a recognizable circle. Center at 0, 0, radius of 6, correct. Now, you see the fact that it's only a radical? That means it's plus. The y is only the positive version. What does that mean? Which part of the circle are we graphing? Like top, bottom, left, or right?
The part above the x-axis.
Yeah, the top. If it were y equals negative radical, it would be the one on the bottom. So graph this. Pretty much you don't have to make a huge production about it. I just want to know which way to slice it. Like this random spot here, they said this was a square. I'm just going to do a little perspective thing here. Yeah, close enough. There. What is the area of a square? Paul. Length times width. Yeah. And what's the volume of a square box? That's for a regular square. Length times width times height, which in this case is very, very thin. What would you call it? Dx, because it's sliced in the dx direction. So in other words, this is something times dx. The volume of a slice. I can hear you. Jack, take over. What's this length?
Y.
It's y. That makes sense. If it's coming from the bottom, the height of the graph is y. What's the distance away from us, like this?
X. Or.
Well, they didn't say it. It's poking out at us.
Oh, it's poking out at us.
But there's something about in the problem that says how long it is. What shape is this?
That's
for no-
square.
It's a square. Therefore, if this is y,
Oh, it's Y.
this is also y. Correct. So it's y times dx. How to get the entire volume? So it's a whole bunch of squares stacked up. Julie Sishan. How to get the total volume? Integral. The integral, take over Pete, from what to what?
The integral from 0 to 6.
What are you using? X's or Y's?
X's. Oh, from -6 to
Right.
6.
If you were doing Y's, it would go from 0 to 6. X's go from all the way from -6 to 6, because you have all these slices. Yeah, does that make sense? So keep going. Times what?
Y squared
Mhm.
dx.
Good. Is there anything stopping us from taking that integral?
The y squared and the dx.
Yeah, what's y really?
Radical 36 minus x squared.
Good, put that in. The integral from -6 to 6 of radical 36 minus x squared, parentheses squared, dx. This actually comes out rather nice. What do you get? What happens now?
So the radical cancels from the square.
Good,
So then you get 36 minus x squared dx.
correct. I have to just plug that in. You could probably do that even by hand, because it's 1/3 x cubed, blah, 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 but as long as the calculator's out, do it. So math 9, 36 minus x squared, comma x, comma -6, comma 6. Then what you get? 288, correct. Which is the right answer. Questions? Does that make sense? Okay. By the way, a friendly reminder, only water is allowed in here. I won't have you dump anything, but for future reference. Because a lot of people's water smell really, really good today, so just saying. Any last questions? All right, take out your notes, please. Welcome to the last section of the chapter.
Didn't you say that yesterday?
I did, I forgot one. I was tossing around whether to include this section or not, and I decided yes. Partially because if I don't, we would have had the practice test today, and I don't think, I didn't quite prepare you for that. Yeah. Oh heavens, yes. Okay. And remember the exact answers when all possible.
That was the one. We will read it.
For those who thought you escaped physics, I apologize.
Oh, we do.
Absolutely not.
No, I'm not doing this today.
Not doing physics. Today's Thursday. We don't have physics class on Thursday.
Right. I'll give you hopefully a more pleasant version of physics. There are two aspects of physics we've ever covered in this class. One was that big section on particles moving back and forth on the x-axis, finding acceleration, yada, yada, yada. This is a little different. This is, way back when, physical science. There's a formula. Now, I'm not talking about work in the metaphorical sense of being productive. I'm talking about work in the physics sense. Does anybody happen to know? It's something times something. Anybody know? I'll tell you if you don't. Has anybody seen this before? Sometimes they cover this in like 7th grade science. What's that? Force times distance, correct. Work is equal to force times distance. What this means, quick question. I'm gonna hopefully not, well, no, I better not do this. Rats. Because I want to be on screen where the people online can do this. Tell you what, right here, watch my water bottle. Have I done any work? Yes. Explain. Yeah.
You use force to move it over.
Yeah, I used force to move it through a distance. Watch this. Am I exerting force right now? Yeah, to hold it up. If I stopped exerting force, splash. Am I doing any work? No. Force has to go through distance in order to be work. You could be sweating and exerting yourself and just about ready to collapse and not do any work. For example, let me show you work. I just did work. Let me show you this. I did no work. Okay, it makes sense? You have to go through distance in order for it to be actual work. Okay, hopefully that'll weld it in your mind. Now, these are measured in certain units. Force. There is an English system, and there is a metric system. Does anybody happen to know the metric unit of force? The metric unit of force. It's the Newton, correct. Named after Sir Isaac Newton. It's abbreviated by capital N without a period. I've sometimes seen it NT, but N is yeah. Go for it. Everybody got this so far? Does anybody know the English unit of force? There are actually two possible answers to this. There's one more common and one less common that almost is never used. This is the most common one. Pound. Pounds of pressure or pounds of force. It's abbreviated LB period. I think that's from Libras, which is I think that's Latin for pounds. There's an older type called a slug, which I just, go look it up if you want. It's not, we're not using it, but it's fun to say. Distance. The English unit of distance, if you're not talking huge distances, like just in a classroom, what's the most basic unit of English distance? I mean, just off the top of your head. Yeah, the foot. That's FT period. What about metric system? What of the metric system? Meter. It's the lowercase m with no period. Okay? Work. Now work is force times distance. What unit would they use for work in the English system? Has anyone heard this? I'm surprised that very few classes teach this anymore. Because everybody's just going gaga over the metric system, which I understand. It's decimal, it's all lovely, but I'm not making this up. The foot-pound.
Seriously?
Yeah, you have like 100 foot-pounds of work in the English system. They just said feet times pounds is foot-pounds. What, they don't call it pounds feet? I don't know. I guess it was alphabetical order, distance, whatever. I'm just guessing. So the abbreviation, FT period hyphen LB period, foot-pounds. That was actually a very common unit of force, or work rather. Distance, you're gonna think I'm making this up, but there are actually two different names for this. Anybody know the common one? In physics, you might have heard of this. It starts with a J. Joule. It's the joule. It's abbreviated capital J with no period. But there's another name for it. Newton meter, which is abbreviated N-M. We're going to use joules, but I always thought Newton meter sounded fun. Everybody clear on these? Make sure you know which one is which. You need to be familiar with these units, otherwise the actual story problem is not going to make much sense. Quick example. My instincts are telling me to give you a quick brush up on metric conversions. Not metric to English, those are annoying. You just look those up. I mean, you can memorize a few of them, but for example, how many centimeters are in a meter? 100. How many meters are in a kilometer? 1,000. How many hectometers? Oh, sorry, how many meters in a hectometer? Have you ever heard hectometer before? 100. Let me show you these. 1,000 is kilo. 100 is hecto. 10, let me know? Close. Deci is 1/10. Deca, very good. Deca. 1 is just the unit itself, like the meter or the whatever. Now 1/10 is what? That's deci. What's 100th? Centi. And 1/1000? Not quite that far. Millimeter, for example, or milligram. Make sense? Yeah.
How big, like the metric, like as an acre, like a hectare? How much is a hectare?
A hectare is one, let me see. I think it's, man alive, I used to know this, hold on. I think it's 100 meters by 100 meters.
Okay.
So, and it's, I forgot what that is compared to an acre, but I think it might be a little bigger. There are a few others.
Plug your ears.
It goes up and up and up and up and up. Let's not lose focus, please. Let me know 1 million.
Micro.
Anybody who's familiar with computers might have known this. Now,
Oh, this is.
memory has gotten so big so fast, you might not even have known. There are kilobytes, which are, they're like ancient now. People say, what? Giga's too big.
Mega.
Mega. 1 billion.
It was in September.
1 billion is giga. Let me know 1 trillion. Tera. Very good. Let me know what's beyond that.
Portera.
What? It's quadrillion. I'd have to look it up actually. It's a zeta, it starts with either an X or a Z.
Ziga.
It's really, I can't even remember. I'll have to look it up. But
That's a great one.
1 millionth. Let me know it. There's deci, centi, milli,
It's in nano.
micro. How about 1 over a billion?
Nano.
Nano. Very good.
I knew one of these times I would get it.
I knew
One of these
them
is gonna
was
be
nano.
And I remember there's an attometer, ATTO. Maybe that's the big or small. I'll look it up. But the ones I'm focusing on are the common ones. From 1,000 to 1 over 1,000. The other ones are just icing on the cake. So here's a question for you. A block is moved 45 decameters using 2.6 newtons of force. Find the work done.
There's gonna be a lot of
Try that. Back to math. If a block is moved 45 decameters using 2.6 newtons of force, and by the way, there is a way to get your own force, like to calculate how many newtons there are. That's a topic for another time. I'm just gonna stick with these for now. Find the work done. How? The actual math is not that hard. You just have to make sure you know the units. What is the basic, what is the basic unit of work? First of all, is this metric or English? Do this. Metric, yeah. They're talking about meters and they're talking about newtons. So it's metric. What's the basic unit of force, or of work rather, in the metric system? B.
The basic unit, a joule or a newton meter.
Right. Newton meter, remember, Newton is just newtons times meters, or a joule. Now, how do you find it, Jack?
Oh. What? Sorry, I was still writing down some of the other stuff.
Answer this.
All right, so we have force times distance, basically.
The work is force times distance, okay.
So work equals 45 decameters times 2.6 newtons.
Good, just a second.
But we could change, you could do like a conversion factor to get decameters just down to meters.
Correct. What is that really?
So
A decameter is how many meters?
10 meters.
10.
So 45 divided by 10.
Is deca big or small?
It's bigger.
Bigger.
So it's, hold on. It's times.
Yeah.
So
What do
you
you
have
got?
450 meters
Right.
times
Times.
2.6 newtons,
Go for it.
1,170 joules.
Probably. Hang on a second. 30, second story is 24. Second?
I said 1,170, but maybe I typed it in wrong.
Okay, well, maybe I get
It's
it wrong.
450 times
It's about
2.6.
30. Oh, I carried the 3, duh, you're right. So 11700, and how many decimal places do I steal back?
1,
1. So yeah, so what's the final answer?
1.1, wait, I mean 1,170
70 what?
joules.
Joules.
Okay.
Correct.
That's
So we feeling okay on this? Again, this is not calculus. This is just plain old dirt level physics. Calculating work. You may just have to do a couple of conversions depending on what they give you. If they give it to you in inches, you convert it to feet, divide by 12. If you give it to you in kilometers, convert it to meters, multiply by 1,000, etc. If it's a big unit, make sure you multiply. If it's a small unit, make sure you divide. You okay so far? Now, where calculus comes in, and I'm just going to give you a teaser here. Drawing, is everybody okay with the units? We got this in the notes? Okay. I'll keep the multiples up there for a little bit. Suppose, for the sake of argument, here's a bucket with a handle, with a rope, tied to a hook. Is it okay so far? You're going to lift this bucket up, 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 up. Couple things you need to know. The bucket is full to a certain amount of water. I'll tell you this much. The bucket, normally we measure a bucket in pounds or something like that. I'm going to measure it in newtons just to make it easy. The bucket weighs 3 newtons. The water weighs 7 newtons. The rope weighs 2 newtons per meter of rope. So if you have lots and lots of rope, it's going to weigh more. Does that make sense? This distance is 50 meters. You with me so far? I want to lift to the top. So question, just with the bucket, nothing but the bucket with the water, how much does that weigh in newtons? Yeah, good. 10. Does that make sense? This whole stuff here is 10 newtons total. If that's all you were lifting, how much work would you do? You could probably do it in your head. Probably. You just ignore the rope. If all you did was lift this bucket all the way up to here, how much work would you do? 500 joules. How do you get that? 50 times 10. Make sense? So it's force times distance. Is that going to be our total work? Is it going to be more or less? More. I don't know why.
The rope also has.
The rope has weight. By the way, at the very, very bottom, how much rope weight are you lifting? When you're first starting? None. The rope is hanging from this hook. The hook is holding up to all the... Now let's say you get like halfway up. Does it make sense that half the rope is in the bucket? You're now lifting half of the rope, which weighs something. Does that make sense? So as you raise the bucket up, what's happening to the weight of this thing? It's getting heavier and heavier and heavier until it gets to its maximum heaviness and you're carrying the whole rope when you get up there. But you see that it's going to increase gradually? This is tricky. how much total work have we done? It keeps changing, we don't know. It's gonna, I'd love to just say, well, 10 times 50. If it stayed constant, yeah, it would. But if it goes 10, 11, 12, 13, 14, 15, 16, 17, how am I supposed to do that? Remember, work equals force times distance. Question. The distance is going to be what I call gradual. Go ahead and write this down. This is very important. I'll explain why in a minute. Gradual movements. I mean that in two senses. There's the modern sense of gradual meaning slow, and there's the ancient sense of gradual meaning, in science, have you ever played with something called a graduated cylinder? Anybody know what it is? Look, what is a graduated cylinder? It's a piece of lab equipment. What does it do? What does it look like?
Column measures how much liquid is in it.
Right. And anybody know why it's called graduated? It's not because it has a diploma. Did you find out why it's called graduated? This is why it's called graduated. The marks. These are gradations. Otherwise known as graduations. Which sounds funny to our ears. Because we think of graduation as commencement from high school. But graduation, something that's graduated is sliced, measured, step by step by step. Graduation means in steps. So gradual movement means movements in teeny tiny steps. So, let's try this. Question, look up here. We only got like 4 minutes. The force in this setup, does it stay constant? B. When I'm lifting this bucket up, in this particular setup exactly as you see it? No. Does the force increase or decrease as you go? Lift, 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 lift. Yeah, why?
Because you have less of a distance.
Less of a distance, won't you? Because here, let's say I'm trying to lift this to the ceiling. There's less distance, less distance, less distance, but it's the same force. The force is how much exertion I need in order to lift it. As I lift that bucket up, does the force stay constant, Jack?
As you're lifting it up, yeah, it would stay constant.
This was answered earlier. Anybody tuned in? Go.
No, it gets
No,
larger.
it gets bigger and bigger. Why? Okay.
Me?
Yeah.
Oh, because the rope is.
You're getting more and more
graduated.
rope in the butt. You just tuned out. This is why you don't know the answer. If you pay attention 30% of the time, you're gonna miss 70% of the material on the average. Bad choice. Let's try this again. When you have a bucket and you're lifting like this, the rope is gonna start piling into the bucket. You're gonna be lifting more and more rope. Does that make sense? That's why the force needed is gonna get more and more and more. So if you get up near the top, you're gonna have most of the rope in the bucket with the water. And it's gonna get heavier, 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 okay? So force is changing, it's variable. It's not constant. Please don't talk about extraneous things. It can wait. Seriously, 2 minutes. This means we're gonna have to do this. There's going to be a force function. Something will have to tell us how much force there is at any given point. Force function dependent on the distance. How much distance you've covered. Because the more distance you cover, the heavier the thing is. And the distance itself, remember, it's only going in tiny steps. Gradual movements, in other words, tiny steps. Where have we heard that before? In this class. When you have tiny little steps We also sometimes call them tiny little what?
dx, ds.
Yes, slices. In other words, they're slices of distance. D, whatever the variable for distance. I'm not gonna use D for distance, because that'd be totally confusing, dd. But, here's a question for you. If I'm going up, normally I use the letter Y for going up. There's no cosmic reason you have to. Would I freak anybody out if I used X? Let's say X is the number of meters moved so far. You can use any variable you want, honestly. You could use A, you could use M, I suppose, for meters. Does that kind of make sense? So what we're gonna need, we're gonna have a force function dependent on the distance times a very small movement. Guess what I'd call that? If X is how many meters you've moved, what's a very, very, very small slice of that? Dx. So it's going to be something times dx. And this, we're gonna do tomorrow, because we're out of time. But we'll need to find, actually it's a first year algebra problem, believe it or not. Finding the formula for how much force, because we can keep track of it. Like after 10 meters, how much does it weigh? After 20 meters, how much does it weigh? And we can find a formula for it, which we will do tomorrow. There is no homework for tomorrow. Rejoice, be glad, go pass a humanities test or something. And please stand. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Alrighty. See you later. Somebody hit the recording. See y'all later, y'all.